If we want to find the domain of a piecewise function, it's a completely straightforward process. All we have to do is combine all of the different pieces of the domain. All of these restrictions on x essentially tell us what values of x we can take as input to our function. So we just look at all of these inequalities and we find all of the numbers that satisfy at least one of them. We're going to draw the kind of picture that we did way back when we first solved compound inequalities. I'm going to go through and lay all of these numbers out on a number line. And just like when we were solving the compound inequalities, it doesn't matter if they're spaced correctly, just if they're in order. And our inequalities are going to give them to us in order. Okay, so there are all of the numbers that show up as endpoints in here. My first interval includes -2, but not 1, and includes all the points in between. My second interval doesn't include 1 and doesn't include 5, but includes all the points in between. My third interval includes 5 and includes 6 and includes all of the points in between. And then my fourth interval doesn't include 8, but it includes everything that comes afterwards. So I have everything from -2 up to 1, and then from there up to 5, and from there all the way through to 6. So I don't actually have any need for that extra dot at 5, since 5 is included, and the points to either side of 5 are also included. And then I have everything to the right of 8. Here's my domain. To describe that in interval notation, well, here's a piece, here's a piece, and here's a piece. They all have gaps in between them. So I have from -2 up to 1, union with 1 up to 6, union with everything beyond 8, we express as 8 to infinity. And that's all there is to finding our domain. Drawing the picture is useful, especially if you have a very strange domain, like in this example. If you have a simple example where there just aren't any gaps at all, you might be able to write it down just by looking at the inequalities. One thing we won't ever see is an overlap between the domains, because we can't define our function in two different ways for the same x and have it still be a function. Now, if instead of being presented with the formula for our function, we're presented with the graph of our function, and we want to find the domain, we go back to our most basic technique for finding the graph. We flatten the graph into the x-axis. So in this example, well, this piece comes down into the x-axis with empty dots at either end, covering that segment in between. This piece comes up into the x-axis with a filled dot at this point. Remember, filled dots take precedence over empty dots. Comes down into the x-axis with an empty dot here. So we're in between there. And then this piece we flatten into the x-axis with an empty dot here, a filled dot here, and the points in between. Again, we're never going to have any overlap in the domain because this is a function. It passes the vertical line test. What do we see in our x-axis? Well, we see all of the points from -3 up to 1, and then a gap, and then we see the points from 2 up to 3. And again, there's our domain. Just imagine flattening the graph into the x-axis.